Hi guys! Today I'm going to be going over questions 16 through 20 of the 2018 AMC8. Timestamps to each individual question will be provided in the description. Question 16 states, Professor Chang has 9 different language books lined up on a bookshelf. 2 Arabic, 3 German, and 4 Spanish. How many ways are there to arrange the 9 books on a shelf while keeping the Arabic books together and keeping the Spanish books together? So we can think of the Arabic books and the Spanish books as a unit because they always have to be together. So what I mean by that is instead of writing 1A or 2 A's for 2 Arabic books, 4 S's for 4 Spanish books, and 3 G's for 3 German books, we can write this as A, or a unit, one singular unit, and the 4 S's as S, or one singular unit. So now what we have to do is find out the number of ways to arrange A, S, and O. I forgot to mention, all of these are, differentiable. You can differentiate between the books, so they're all different. So this will be A1, A2, S1, S2, S3, S4, G1, G2, G3. So now you have to find the number of ways to arrange AS, G1, G2, G3, and G4, and then within that A and within that S, you have to figure out the number of ways to arrange those books. So let's just look at the big picture first. How do you arrange this? Well, this is 1, 2, 3, 4, 5, 6. That would be 6 books, so that's 6 factorial. Oh, sorry, no, that wouldn't be 6 factorial because there wouldn't be a G4 here. There's only 3 books. So that would be 5 factorial. Now within these units, you would have 2 factorial ways to arrange these 2 books, and let me find the color. 4 factorial ways to arrange these books, because that's 4 spots they can be in, 4 different books, 4 times 3 times 2 times 1. Same logic for A. So the total number of ways to arrange these books are 5 factorial multiplied by 4 factorial multiplied by 2 factorial, and that equals 5,760, or C. Question 17 states, Bella begins to walk from her house towards her friend Ella's house. At the same time, Ella begins to ride her bicycle towards Bella's house. They each maintain a constant speed, and Ella rides 5 times as fast as Bella walks. The distance between their houses is 2 miles, which is 10,560 feet, and Bella covers 2.5 feet with each step. How many steps will Bella take by the time she meets Ella? Okay, so let's think about the ratio of their speeds, or the distance they cover. So Ella to Bella is 5 to 1. So what this means is that Bella is always going to do 1/6 of the work, or 1/6 of the walking, because the total number here is 6, 5 plus 1, and she does 1 of that, so 1/6. So 10,560 times 1/6 equals 1,760. So how many steps would this be? So 1,760 divided by 2.5. I don't really like that decimal, so I'm going to change this to 5/2. So what is 2/5 times 1,760? Well, let's divide. 3, 5, 2, so 704. So Bella will take 704 steps by the time she meets Ella. Question 18 states, how many positive factors does 23,232 have? First of all, let's factor 23,232. So we have a 2 that we can factor out, and an 11,616. Another 2 and a 5,808. Another 2 and a 2,904. Another 2 and a 1,452. Another 2 and a, 726. Another 2 and a 363. Finally, a 3 and a 121, and then that's just 11 squared. So the prime factorization of 23,232 is 2 to the power of 6, because 1, 2, 3, 4, 5, 6, times 3 to the power of 1, times 11 to the power of 2. To find the amount of positive factors a number has from its prime factorization, what you do is you take the exponents, you add 1 to each of the exponents, and you multiply. So what that means is that the number of prime factors that 23,232 has is 6 plus 1 times 1 plus 1 times 2 plus 1. So that is 7 times 2 times 3. That is 42. E. Question 19 states, in a sign pyramid, a cell gets a plus if the two cells below it have the same sign, and it gets a minus if the two cells below it have different signs. The diagram below illustrates a sign pyramid with 4 levels. How many possible ways are there to fill the 4 cells in the bottom row to produce a plus at the top of the pyramid? Okay, to answer this question, let's think about it backwards. Let's start with the plus at the top of the pyramid. So in what cases would there be a plus at the top of this pyramid? Well, that would be if there was either a plus or a plus in the second level, or a minus and a minus at the second level. Now let's think one level lower, the third level. What would give us a plus and a plus here? Well, that would be a minus, a minus, a minus, or a plus, and a plus. What would give us 2 minuses? Well, that would be a minus, a plus, and a minus, and a plus, a minus, and a plus. So let's think about each of these cases separately. Let's call this case 1. Oops, case 1. What is happening? Case 1, case 2, case 3. Oops, case 3, and case 4. Okay, so let's think about case 1. So to get a minus, and a minus, you would have to have opposite signs on each one of those. So let's say the first sign is a minus. Then you need a plus, then a minus to create another minus, and then a plus to create another minus. Or you could have the opposite, a plus, a minus, a plus, and a minus. For the second case, to get a plus, and a plus, you would need either a minus, a minus, a minus, and a minus, or a plus, a plus, and a plus. For the third case, all the way over here, for a minus, a plus, and a minus, you would need either a minus here, a plus here for this plus, and then a minus, or a plus here, a minus here, another minus, and then a plus. And for the final fourth stage or case, for the plus, the minus, and the plus, you would need either a minus and a minus, or a plus and a plus here, or a plus and a plus and a minus and a minus. So total, that would be 1, 2, 3, 4, 5, 6, 7, 8 cases. So that would be 8 possible ways to fill in the 4 cells. Question 20 states, in triangle ABC, a point E is on AB with AE equaling 1 and EB equaling 2. A point D is on AC so that DE is parallel to BC, and point F is on BC so that EF is parallel to AC. What is the ratio of CDEF, or the area of CDEF, to the area of triangle ABC? Okay, let's look at this. First of all, we know that triangle ADE is similar to the triangle ABC, and the triangle BEF is similar to the triangle ABC because EF is parallel to AC and DE is parallel to BC. No, that's not the right one. So we can write that the area of ADE is 1/9 the area of ABC because the length here is 1/3, or AE is 1/3 of AB, and area is just the ratio of side length squared. And we can write that the area of BEF is 4/9 of the area of triangle ABC because it's 2/3 of this length, and the area ratio is just the square of the side ratio. So ACFE, this thing right here, is going to be 5/9 the area of ABC because it's just the leftovers of, or what's left over after 4/9 of the area is gone. So then the area of ACFE is equal to 5/9, or 5/9 of triangle ABC. So then subtract 5/9 of the area, or subtract 1/9 of the area from 5/9 of the area, which is 1/9, to get 4/9 of the area being in this thing. It's 4/9 of the total area of triangle ABC. So the ratio, or the ratio of CDEF to triangle ABC is 4/9, or A. Thank you guys so much for watching. Stay tuned and subscribe for the rest of the 2018 AMCA.